In the last lesson, I said that there was two ways to look at rational functions, and one of the ways was a polynomial divided by polynomial. If this thing happens and it's equal to a function, then that's a rational function. But the way number two, the second way that rational functions can happen is if it happens that x times y gives you a number, a constant, and every time you have these x's and y's, whenever you multiply them together, you get the same number, then this is also called a rational function. This one is called an inverse function. So how could this actually look? Because we're used to graphing things where y equals something with an x, and in the last one I said that y is equal to 1 over x. Well, if we take this x times y equals k, and if we solve it for if we solve it for y, then we would divide by x on both sides, and we would get that y equals k over x. The only difference between this one and what we did last time is k is a constant, x is still the input, and y is still the output. Let's do some textbook problems. Determine if these questions are inverse or direct variation. So direct variation was y equals kx. Inverse variation was x times y equals k. So let's see. 3 times 6 equals 18. 5 times 10 equals 50. 8 times 16, 48 plus 80, 128. Okay, so these obviously aren't inverse variation. So then let's try the other way, where y is equal to kx. This one, if y is equal to kx, then y divided by x is equal to k. So this means that if we take y and divide by x, we could get a constant if it was direct variation. So instead of multiplying, now let's divide. 6 divided by 3 equals 2. Divided by 5 equals 2. Divided by 8 equals 2. So this one here is direct variation. This one says y equals 6 times x. Well, that already matches the formula for direct variation, so this is direct variation. X times y equals 15. So that means whatever x is, whatever y is, this equation for number 3 is always going to give the is always going to give the constant answer of 15. So this is inverse variation. This next section says, assume that it's inverse variation, write the equation for it, and then plug in the number and solve. Okay, so if this is inverse variation, then we have two equations that are true. X times y equals a constant, and the other equation that we might use, I don't know if we will, but the other equation that we could use would be y equals k over x. Okay, so y is 10, x is 5. 5 times 10 equals k equals 50. K is equal to 50. Then it says x is 2. Find y. Well, y is equal to k divided by x, so y is equal to 25. Done. Number 6. Y is 100, x is 120. We have x times y equals k is the equation. 120 times 100 equals k equals 1,000, 12,000. Then y is 20. So if y is 20, then y equals 20, and 20 is equal to 12,000 divided by x, which means that x is equal to 12,000, sorry, too many zeros, divided by 20, cancel out some zeros, divide by 2, x is equal to 600. Next one, k equals x times y. They gave you both of those, so k equals negative 2 times 8, which is negative 16. Then we're going to use that k to solve for y. Y equals k divided by x, negative 16 divided by 4, which is negative 4. All we're doing is we're using the equation that says this is inverse variation. And we can use that equation because back in the very start it says assume that it is. Assume that it is inverse variation. K equals xy. K equals negative 16 times 4. K equals negative 64. Y equals 32. And 32 comes from k over x. So let's plug in. K is negative 64 divided by x. I'm going to write that again. 32 equals negative 64 over x. Solve for x, so we move the x to the left, we divide by the 32. And we get that x is negative 2. This person is driving their car, 45 miles per hour. If they increase their speed, how long will it take them? Okay. So, if we have the equation that x times y equals k, x times y equals k, that means that whatever you put in for x and y, whatever the input is, if you multiply it by the output, it's going to be constant, which means that it's always going to be the same number. If that's true, then if you always get the same number whenever you multiply the x with the y that's related to that x, then if you take x1, if you just take any x and you multiply it by its y, it will be equal to the same number that any other x and any other y, well, as long as those two are connected together, if you take one ordered pair and you multiply it, then you will get the same number as if you took any other ordered pair and multiplied that. So this is just one ordered pair. This is other ordered pair. Any other ordered pair. Because these two things will give the same number as their output, then we can just ignore the number for the output. We don't really need that k, and we can say that x1 times y1 will be equal to x2 times y2. And that's at the top of this notes page here. It says that right there. You're going to learn this again in Algebra 2 for a couple days. But that's 2 years from now. Okay, so it took them 4 hours driving at 45 miles per hour. So the first x and y were 4 hours times 45 miles per hour. And that's going to be equal to some number of hours times 50 miles per hour. So let's divide by 50. Get rid of that 50. Divide by 50 over here. And we get that x equals 4 times 45 divided by 50. You could reduce that fraction, but we're probably going to need a calculator anyway. So let me use my calculator. .6 hours. We could have solved this in a really complicated way with equations, or just because, well, the only hint you really have is that this whole worksheet is inverse variation, so we're going to use the inverse variation formula. Eventually, you'll be good. It takes a lot of practice to be good, but eventually you've had enough practice to where you can just know which equations to use and how to set them up. Next example. For this rectangle, the width varies inversely with the length. So the width varies inversely with the length. To know which one's x and which one's y, let's come up here and let's try to find an example. Oh, it's right here. Y varies directly with x. Above number 4, it says y varies inversely with x. So that means that what comes before the word inversely is the output, and what comes after it is the input. So if we look at this one, it says that the width, okay, so that came before the word inversely. The width came first, so that's the y. Width is the y, length is the x. And we have the equation x times y equals k. But we're trying to find a new one, so this is going to equal x2, y2. So then we're going to take the original numbers. The original numbers is a width of 40, 40 for y, length of 5, so that's the x, is going to be equal to, we need the new width, so that's the new y, and the new length is 20. So then now let's divide by the 20. 5 times 2 equals y2. y2 equals 5 times 2, which is 10 meters. Good luck.